Hello, today I'm gonna talk about wave. This is a picture of the wave. As you can see, first we got the wavelength. Wavelength is the length between two peaks. As you can see, you can easily spot it by looking up between this. This is the peak. Second, we're gonna be talking about the peak or the crest. We can call it both. It's the highest point of the wave. As you can see, we got 1 and 2 peaks in this wave picture. Yeah, you get it right. Okay, third is the amplitude. Amplitude is the distance between the wave and the equilibrium, as you can see. Also, this is the amplitude too. Right here to right here. Fourth is the lowest point of the wave, which is the trough. It's like a truffle, but it's like a trough without the foe, you know. So it's a trough. Fifth is the center line where waves can come into rest, which is the equilibrium. Yeah. Sixth is the amount of wave passed in amount of time, which is the frequency. It's like zzz, yeah, like a zzz. Number 7, wave moving up and down once is a period. Cycle. As you can see, this is one cycle, this is another cycle. So in this picture we have 2 cycles. And then the last one for this picture is the amount of time to complete one cycle, which is period. Okay. This, I'm gonna talk about the longitudinal wave and the transverse wave. Yeah, so longitudinal wave is when the particle oscillates parallel to the direction of the wave, like this. And the transverse wave is when the particle oscillates perpendicular to the direction of the wave, like this. Yeah. Hello. Today I'm gonna talk about rarefaction and compression. Rarefaction is when the particles are far apart from each other, so it's less dense. So you can see right here that when I'm circling, this is the one that is rarefaction. But on the other hand, this is the compression. Compression is when the particles are very dense and close together, like this. You see, like the spring go like that. These can apply to all longitudinal wave. Mechanical wave is a wave that needs a medium to pass through. For example, if sound goes through a vacuum, we cannot hear anything because it can't pass through, because it needs a medium to pass through. But electromagnetic wave is a wave that doesn't need a medium to pass through. For example, light. Yes, sir. This is the phase difference. Okay, as you can see, the blue highlighted part is the phase difference. The phase difference is the difference between position of a wave propagating in the same direction. You can see it does not overlap each other, as you can see. Okay, now this one, we got a reflection. Okay, this is the reflection. Sorry. Okay, this reflection is when light or ray, which is this red line, bounces off a medium, which is this black line. Okay, the law of reflection is when the angle of reflection is equal to the angle of incidence. As you can see, it's exactly the same angle of incidence and the reflected angle, as you can see. You know, this is the normal, it's where it bounces off, so it's the same. Okay, and the critical angle is when the ray reflect instead of refract, when it hits the 90-degree angle. We're gonna talk about refraction. Okay, this is a diagram of refraction. Refraction is when it's the bending of light between two mediums, as you can see. First is the air, and then the water. Do you know why it moves so much faster in the air? Because it is not that dense. It is not dense like the water. It is less dense, as you can see in this text. When going to a denser medium, the change of speed will decrease, which is it will slow down, as you can see. And with this less dense, it will be very fast, like that. Refraction can be different depending on the medium and the refractive index. This is the diffraction. The diffraction is when a wave passes through a narrower object and then spreads. So imagine when you're swimming, you go like yeah, and then to get the maximum diffraction, you just have to match the wavelength with the gap size. Yeah, like okay. Wavefronts are the line that connect the line of waves that are in the phase with each other. You can see it's this is the line of wavefronts. Okay, this is the direction of propagation. Propagation is when the waves are widely spreading, as you can see. This is the wave speed. As you can see, wave A is very low frequency, which means the wave speed is so low. But the wave B is very high in frequency. That's why the wave speed is a lot. The wave speed is the amount of distance the wave has traveled in a specific amount of time, as you can see. Boombox, baby! Boombox, baby! Pew, 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 pew! Okay, this is the intensity. Intensity is the amount of energy that the wave carries through a certain area. Yeah. This is the formula. I equal P over A is the power over acceleration. I mean area, sorry. Intensity is the power over area, as you can see. Like a rhino kilo. This is the final episode of physics. This is the boundary. Boundary is the point or the line where two regions meet. As you can see, the wave goes through one medium, which is air, and then another medium, which is water. The line of boundary is this line. The line of boundary is where two mediums meet, as you can see. Air and water. Like an air sa na lak. Quick update, I forgot to do the Snell law. So this is the Snell law. This is the Snell law. Snell law is the law that shows how light bends when it passes from one medium to another medium, depending on the refractive index. Yeah, as you can see, this is medium 1, this is medium 2. Medium 1 is air and medium 2 is water. So it shows how light bends, as you can see. Boop, boop. And this is the formula for the Snell law. And this is for the units. N is for refractive index and theta is for angle of ray.